All right, no. Okay. So yeah. Okay. So just remember that again that they have. I mean, the perpendicular lines gradients are negative reciprocal of each other. Okay. So which example? All right. Now let's continue with example number 19. Now this question here or this example has a lot of questions. Okay. So I'm going to break down each question piece by piece. All right, so let's have example number 19. Now, on example number 19, you have 3 points, which is A, B, and C. This one. Okay, so find letter A, the equation of the line through A perpendicular to AB. Now, when you say through A perpendicular to AB, through point A, of course, through point A, and then which is perpendicular to AB. So, here is AB. All right. So again, this is the line and then perpendicular to AB. So it creates a 90-degree angle here. All right. So what we're looking for here is this line through point A. All right. This line here. Now, again, it says here that this line is perpendicular to line AB. So therefore, how am I supposed to get the equation of this line? So same thing goes with perpendicular lines. You need to find the gradient and you need to apply the formula. Okay, this one, x of 1. And then there you go from there. Now, first things first, how can I determine the gradient of this line? Right now, if this line here is perpendicular to line AB, therefore, their gradients are a negative reciprocal of each other. So, is the gradient of line AB given? No, right? But you're given 2 points, which is point A and point B. So from here, you can get the gradient of line AB. So that's what I did here. All right, so we find the gradient of line AB, and then from doing so, our answer is 2/3, okay? Or negative 2/3, sorry, okay? And then, therefore, if this line is perpendicular to line AB, again, that will be the negative reciprocal of negative 2/3, right? So negative reciprocal, you flip this, and then you multiply it by negative 1. So that's why now I know that the gradient of this line, let's say line AB, is 3 over 2. All right? So any question on this part? Okay, none, right? So again, negative reciprocal of this one since they're perpendicular. Now, so we now have our gradient for this line, right? So we now check for the gradient. So what do we need to do next? We need to find the equation of the line by using this formula. Y minus y sub 1 minus m times x minus x sub 1. So substituting m here and then using point A, negative 1 and 4, you substitute all the values here and then you'll end up with y equals 3 over 2x plus 11 over 2. So that is the equation of this line, line AB. Any question, class, for letter A? Okay, now, all right, now let's continue with letter B. Now, for letter B, we need to find the equation of the line through C, parallel to AB, or line AB. Okay, where's that line? Through C. So this is, okay, this is the line that we need to, that we want to find the equation. So this is the line, and then it says here that this line is parallel to this line. All right. So again, what is the definition of parallel lines when it comes to their gradients? So parallel lines have the same gradient, right? So that's why, uh, do we know the gradient of line AB? Yes, right, from letter A. So therefore, the gradient of line CD, which is parallel to AB, will also have the same gradient, which is negative 2/3, right? So this again came from letter A, from here. Okay, this one, its gradient is negative 2/3, and then since this is parallel to this, they have the same gradient, so same, negative 2/3. So therefore, from there, we can now find its equation of line CD by using this formula again. So y minus, so I'm using point C, so you have 7 and 3 here, and then same gradient, which is negative 2/3. So simplifying this, you'll get y equals negative 2/3 x plus 23 over 3. All right. Any question, class, for letter B? Okay, none. Now, for letter C, we need to find the coordinates of the point D at which these two lines intersect. So, you have here point D. Now, as you notice, class, this point here is the intersection point of line AD and line CD, right? So, how are we supposed to solve and find the coordinates of point D? So again, we solve this simultaneously. That's why I have this equation 2 here and then equation 1 over here. So you have your two equations. So we need to solve them simultaneously for the values of point D, or x and y values of point D. So doing so, okay, let me go here now. So this is equation 1, this is equation 2, right? So they're both equal to y. So here, I'm just going to solve them together. Since they're both equal to y, therefore, these two expressions are also equal to each other, right? This one, okay? So this is where you begin from here, right? So basically, of course, you need to combine all like terms. So you need to transpose this, you need to transpose this here. Simplify this, you'll get 13 over 6. Simplify this, you'll get 13 over 6. Therefore, x is equal to 1. Okay. And then for your y value, you can choose either equations. So I choose equation 1. And then substituting 1 here, y is equal to 7. So therefore, the coordinates of point D is 1, 7. Any question, guys, for letter C? All right, now, okay. Wow, last question from example number 19. Now, this is just a gimme. The distance of AD. So everyone knows this. This is the distance formula. Okay, so point A is over here, point B is over here. So this is the formula. Substitute everything here. Your answer will be equal to root 13 units. Okay, let's see it. Sorry. So it says here that the line y equals ax plus b is perpendicular to the line y minus 3x equals 4 and passes through the point 1, negative 2. Find the value of A and of B. All right. So again, you have here two lines, all right, which are perpendicular to each other. Now, first things first, I want to rearrange the second equation. It's because this is not yet in standard form, so it should be in y equals mx plus c format, right? So rearrange this, so it will become this one. Y equals 3x plus 4. Now, look at these two equations now. Now, if they're perpendicular to each other, okay, the gradient of the second line is 3, right? It's 3. Therefore, if I compare this to this, the value of A should be a negative reciprocal of 3. So that's how I got the value of A. So therefore, A is negative 1/3. It's because, again, this is the gradient of the second line. Again, if you have two lines which are perpendicular to each other, and then the gradient of this line is 3, therefore the other one is negative 1/3. Negative reciprocal. Okay? So that's the value of A. So by just mere comparison, and then you should know that they are a negative reciprocal of each other. So it's negative 1/3. Any question, class, for letter A? Or how did I get this? Okay, so that's it for A. Now for the value of B, I'm going to use the first equation. Since I know the value of A, and I know that this point here will pass through -1, 1 and -2. So I'll use this and then substitute the given value. So A is -1/3, and here is 1 and -2. Okay, so therefore, solving this, B is equal to -5/3. So those are the values of A and B. Any question, class? All right, now let's go to number 7. Okay, I'll finish early today. I'll just give you guys a homework for Monday. All right, so that's it for number 6. Any questions? Okay, now let's go to number 7. Now for number 7, again, I told you to try to make a sketch of this question. Now for number 7, let me read. 3 points have coordinates A, 3, 6, B is 2, -1, and then C is 6, 7. The point F is the foot of the perpendicular from A to BC. Okay, foot, the lower part of the line. Find the coordinates of F, hence or otherwise find the perpendicular distance from A to the line BC. So first things first, you make a sketch of these 3 points. Okay, so as you notice, your 3 points will be like this. Okay, now, okay, so BC, all right, that is your first line, BC. And it says here, point F is the foot of the perpendicular. So there's a line through point A that intersects this line BC, which makes them perpendicular. So this point here that intersects line BC is point F. This is basically called the foot. Okay. All right. So that's it. Or foot of the perpendicular, this one. Okay, so basically it's point F, right? This one. So that's how it's going to look like. Now, what we need to do for number 7 is we need to first find the coordinates of F, of point F. And how are we going to do that? Now, we cannot use the midpoint formula because, of course, it's not in the middle, right? The question doesn't say that. So what we can do is basically we need to find the equation of this line BC, and then also we need to find the equation of this line AF. And then once we get our two equations, we can solve them simultaneously. All right? Okay. So let me find the equation of the line BC first. Okay. Again, when you want to find the equation of the line, you need the gradient and a point, right? So here's your gradient of line BC, which will give you 2, right? Since it's going up, it's supposed to be positive. Okay. And then using the formula, so substitute all the values here. So m becomes 2, and then just choose either point B or point C. Okay, either way, it will still give you the same equation. So here I went for point B. So here's here is +2, and then this is -1, right? So therefore, simplifying this, your first equation is 2x minus 5, or y equals 2x minus 5. Any question, class, for this? So that's the equation of line BC. Now next is, I'm going to find the equation of line AF, this one. All right, okay. So now I don't have to solve the gradient of line AF. It's because I know that this is perpendicular to this line, right? So therefore, the gradient of line AF is a negative reciprocal of the gradient of line BC. So getting the negative reciprocal of 2, it is -1/2. Okay, so that's it, -1/2. So maybe you're still wondering, how did I get -1/2? Reciprocal, you flip this, it becomes 1/2. And then when you add the word negative, you just multiply it by -1. That's why this is -1/2, right? So therefore, I have my gradient, so I can now find the equation of this line using this formula. So here's the gradient, so it's -1/2. And then for the x and y value, I just use the values of point A, which is 3 and 6. Okay. So from here, simplifying this, your second equation is y equals -1/2 x plus 15/2. Okay, any question, class, for the equations of line BC and line AF? Okay, none? All right. Now, how do we find for the value the coordinates of point P? Now, to find for the coordinates of point P, we now need to solve them or solve this one simultaneously, right? So here is my first equation, and then my second equation is this now, right? So it came from here, and then I just remove the fractions by multiplying this equation by 2. So when you do that, okay, you'll get 2y and then cancel this. That's why this is now just 2y equals -x plus 15, because of course we don't want fractions. It's too tricky, right? Okay, so here are your two equations. Now I'm going to use substitution method here. So since y is equal to 2x minus 5, I'm going to insert this into the value of this y over here. Okay, so writing this and then substituting the value of y, which is 2x minus 5. So this is now your equation. So you need to solve for x. Now solving for x is equal to 5. All right, and then solving for y, okay, it's up to you with this one or this one is okay. So solving for y is equal to 5 as well. So therefore, the coordinates of point F is 5, 5. So this is 5 and 5, which makes sense because it's over here and then over here, which is next to 6, right? So that's it. That's the coordinates of point F. Now, there's another question. We need to find the perpendicular distance from A to the line BC. When you say perpendicular distance, it is just basically the distance formula. This question is just asking how far is point A from point F, which is in line BC. So this is the question here. What's the distance between point A and basically this line? So for this one, you just need to basically find the distance of AF, right? So using the points A and F, substitute all values here. Therefore, your answer is equal to square root of 5 units. So that's it. That's your answer for number 7. Okay, any question, class, from number 7 or number 6?